Hello friends, I am Dr. Amit Ahuja, Assistant Professor from University School of Education, Guru Gobind Singh, Indraprastha University, Delhi. Today, we will discuss science as a process. What science is? What does it mean by the term that science as a process? What's a process then? All these aspects will be discussed here. Regarding what is science, in a statement form, I can say that it is a way of describing and explaining the aspects of the world around us. That means exploring the world around me by describing and explaining. What's the difference between them? First of all, we should know that to explore the world around us, we focus upon why aspects, how aspects, and what aspects related with that matter around us or environment. That is, that matter or the environment can be exploring by working on the what, why, how aspects pertaining to it. For example, what is photosynthesis? If I ask this question to some student, the child will retrieve before me in a one breath that preparation of food by the plants in its green parts in the presence of sunlight is known as photosynthesis. Why? Because I have asked what is science, what is photosynthesis. But if I say, how does photosynthesis take place? Then it's some tricky in the sense that there is a photolysis of water in the presence of sunlight, and then starch formation takes place, and then there is this much cycle and oxygen is evolved, and it takes place in the chlorophyll that is located in chloroplast. But sometimes do remember, students find it difficult to discriminate between chlorophyll and chloroplast. They say in a reverse manner, that is chloroplast is in chlorophyll, but the chloroplast is a cell organ, chlorophyll is a pigment. So that is how aspect of that phenomenon. Why does photosynthesis take place? Now it refers something else. That means there are two modes of nutrition. What is nutrition then? First, procurement of energy liberating substances is process of nutrition and nutrition. There are two types of nutrition, two modes of nutrition, that is autotrophic and heterotrophic. Autotrophic means the living body synthesizes the food by itself own, like plants, they carry out photosynthesis. Heterotrophic means organisms depend upon others, autotrophs, for their own survival through food, that is heterotrophic. So you see, insisted upon what aspects, it required only retrieval of definition. But when I probe how aspect, then it referred to mechanism of that process. But when I probed upon why aspect, that means the rationale behind that phenomena going on in nature. When we describe a thing, that means what aspects, and it refers to a certain degree how aspect. But when we explain a thing, that means it should focus on why aspects. So describing that is what and how, explaining the why aspects of the things around me. What is this? How does it work? Why it is so? For example, these are the aspects that can be explored. So the science is a such kind of way that has this much methodology. Then science teaching for science teachers involves and it requires that their learners should be exposed in a scenario where they can themselves investigate at their own, or by the support of teacher as a facilitator. That is, science teaching implies involving the learners in the investigation so that they become scientists for the day. Children are curious and energetic by nature. So imagine if a student in the science lab wears a scientist's coat, shakes some test tubes, records some observation, writes some data in his or copy, then imagine what would be the degree of interest in his mind for sciences. Do we do so in real practice? No. We just only narrate science as like other subjects. Science has different nature. So that's why there should be different way of, in a positive way, teaching science. Then after that, what science is refer to the theories, facts, concepts and a way of working all together. How do all the work constitute the body of knowledge, that is as a science. Then after that, science is not just mere a content, but it is more than that. What's more than that? That is process. Science is not just presentation of content, but how did we arrive at that content is the process of science. Science is not just mere telling about a content, but how did we arrive at, come at that content. That is the process of science that should be taken into account. So just not letting them water boils at 100 degree, it's enough, but let them show how does it boil and what is the meniscus sign that should be taken into account. That means the water has boiled there now. What is the use of porcelain or any other apparatus being utilized for that process should be shown to them. They should be well aware about that. So just by knowing that water boils at 100 degrees Celsius is not enough. They should know how to set up the apparatus to show that water boils at 100 degrees Celsius. Science regarding content. Familiarizing the learner with theories and concepts support them in developing a conceptual structure. Yes, for example, what is Archimedes' law? Lamarck's theory of inheritance of acquired characters. What is a parallel plate capacitor in physics? What is Venn diagram generator, etc. What is Corlach's law of electrolysis, and so on. So you see, the student must be familiarized. There cannot be compromise with the quality of content. That means we should ignore this and we should focus upon the process approach. No, that is content plus process. Both are equally important. So that is their familiarization with all these aspects is a very important aspect. Then mere teaching of concept even does not put them in a position to explore, investigate, experiment, but it unfortunately it puts them in a passive site. That means you have to listen only. You can't add, you can't explore, you can't investigate, experiment. You have to just read science. You cannot confirm science. You cannot explore science. You cannot imagine science. So if we just go on reproducing, belching content as a learner, as an advanced learner on the part of teachers, I would like to say, won't work. And that's a plausible reason that's why science courses at senior secondary level are not opted by the students, because there is no difference between teaching of science and other academic subjects. Then after that, regarding the teaching of content, if we teach them, go on teaching them as a conventional or traditional practice, the learners over a period of time develop a perception that science provides no opportunity for them to express, imagine, or any kind of creativity. They have to just mug up like other subjects without any understanding, score marks, good or bad, whatever it is, and then say bye-bye to that content. When they encounter in another class, because of spiral nature of science curriculum, they have to start afresh. For example, the chapters on metal, etc., electricity, they came at upper primary stage, secondary stage, and at senior secondary level. But since they are not taught with respect to process approach, many students find it difficult to again revive it. So that's why if they would have been taught by process approach, then within a short duration, they can be again in that position to learn up and be ready for the further learning. So mere teaching them conceptual understanding or dumping the information just puts them in a passive position. So what should be done then? If you go on imparting the instructions into the classroom, preparing them to retrieve in the examination, score good marks, and prove that you are a good student, what should be done that to avoid such kinds of disliking for sciences? Science should be presented in a manner that facilitates the learner to conduct an inquiry. Yes, it gives them some space to explore, asserts, raise finger on sciences, why it is so. So that means the doors of the science are not closed for them. Even a learner, even a novice can explore sciences, through sciences, the world around him or her. Then science, again I say, is taught as a body of knowledge, but not as a way to develop this body of knowledge. Unfortunately, this has been the practice over the years because of dominance of examination system and ritual of imparting in a rigid curriculum. So that's why there is no scope of creativity, etc. on the part of learner. Then how to involve the learners in scientific inquiry by the teacher requires that they should put them in a state of inquiry. And this model that's present before you, that is problem to hypothesis to experimentation and to result, is the basic sequence of steps that can be used to put them in a state of investigator. Problem must be perceived or sensitized by them. For example, the things around them. If we ask them, students, what problem did you encounter while coming to school from your home? What problem do you face while going from school to home? Or in outside world, what do you feel? For example, like pollution, population, environmental changes, etc. are the problem or the need of the hour that must be thought upon. So if we cannot give them scope for hypothesis or experimentation in laboratory, or then there is no question of finding the results, then at least we should sensitize them about the surroundings around them. What's going on there? Is all okay? Kindly criticize this. What is criticism? What is critical thinking? That is comprehending the things around you and then filling the gap into that. If you can't fill that, then suggest the way of filling the gaps. So when a problem is perceived, experienced by them, reporting by them, the next step is what is the intelligent guessing, or through what intelligent guessing, what can be the tentative solution of that problem. Okay, this could be the tentative solution of a problem. Then after that, go for experimentation in the laboratory if things permit us, or go for conducting activities outside the laboratory also if the things are in nature. Then collect the data, work out that is data analysis, and then arrive at the result, that is hypothesis or accepted or rejected. All this requires that we must view science as a process, not science as a product. Actually, the science should be viewed as science as a process as well as product. But what we unfortunately do is that science as a product only. So science as a process supports, substantiates the nature of science as a science body of knowledge. What are the different processes associated with science? Like this, observation. What is observation? That is only seeing? No, it's careful seeing. And then inferring what's going around me. Be sensitive. Be open to the things around you, the happenings around you. Observe the things as such and let the things happen at their own end. Don't interfere. Then after that, classification. That is grouping the individuals or the objects based on certain similar characteristics. Classify them. Classification. Using numbers. Definitely without quantification you cannot be precise enough. For example, if we say roughly it takes this much time, roughly doesn't mean be precise, be particular in saying so that this much time is taken from arriving from here to there. Be accurate, be precise. One. Measurement, that is diagnosing, assessing its dimensions and reporting this in numbers. When I was working with some 6th class students, I found them, they were not able to measure even with a scale properly as was supposed to be. So if a teacher goes on teaching them about measurement, that is conversion of meter to centimeter and vice versa, is not sufficient. First of all, we should assess, can they measure? For example, if we go on teaching the concept of heat at senior secondary level and the child cannot measure the temperature through thermometer. However, nowadays it's possible that electronic thermometers are available that one can easily measure, but measuring them through mercury thermometer could be something errorful. So mere teaching them is not enough. So process approach is enough. So process approach, the one of the important component of that is measurement. So student should be well equipped with this skill. So teacher should ensure that does my student know measurement? Using space-time relationship. Yes, definitely there is a relation between them. For example, one person can be at one time at one place only. It's not possible for a person to be at two places at one time or at one place for the two times. That's illogical to say. So using space-time relationship, what does it happen? Why does this happen at different places in different time zones also? Communication. Are you able to convince others? Are you able to apprise others about your understanding or what you know, etc.? What communication is that? Communication is a process in which there is a sender that codes the message, and through some medium, like at this time, the medium is my language, spoken words, and before you is the text. So through these channels, the acceptor decodes that messages, and then the process of communication is completed. But do you remember that channel should not be porous, so that information is not filtered out, information is not leaked out, and there should not be multiple so much channels so that information may not be diverted from the actual target. Science definitely predicts also, but that prediction must be some logical one, in the sense that if I have this hypothesis, then what do I predict to get by it? If I sow these much plants in this field, what do I predict? So that means some rationale, some logic behind this. Inferring. Am I able to deduce something meaningful from the given statement or the given situation or the given data? Do I have the skill? So if I don't have, it is useless if I have so much information with me, because I cannot infer. So finding certain commonalities, classifying them, support me to infer also. Defining operationally. Yes, for example, if I define certain things, then in what way it can work out in my given project, or what I'm intending to by this. What does it mean by it in my case? For example, if I'm conducting some experiment, so that it should not be some hypothetical or in a mere storytelling or a fiction way. Then formulation of hypothesis. These are the skills that we are discussing. That is, our science students should be well equipped in classrooms through our teacher. Formulation of hypothesis, framing of hypothesis. Am I able to frame some guessing, intelligent guessing through observation, experimentation, etc. also, or not? If I cannot, that means this skill is lacking. So to what I will test then? If I have some idea in my mind and I have to test this, then first of all I must frame a hypothesis. What I am intending then? So hypothesis means what you are intending then. Let us test that. After when the testing starts, you get data, and the data is analyzed and interpret the data. Do you remember there is a difference between data analysis and data interpretation? Data analysis can be done through quantitative as well as qualitative manners, but interpretation means what it leads to. What does it mean? For example, mere frequency counting for in survey is not enough, it's not a research, but what it leads to is interpretation of that. So data interpretation is very important for science students as a process. Controlling the variable. You see, if we control a variable, that means we are able to show its effect on the dependent variable. For example, water is a universal solvent. Fine. To prove this, I will take as an experiment that I will dissolve some salt in water. It gets dissolved. For example, if I take in place of water mustard oil and I dissolve salt in that, it may not. I leave this as an open-end exercise for you. It won't. So that means that's a control of that experiment to prove that water is a universal solvent, because water was manipulated by mustard oil, so salt cannot be dissolved. So are you able to control the variables? This is our manipulation of variable, that in this example. Now I come to control the variables, that is avoiding certain intervening variable to interfere in the experiment. For example, if already soluble, semi-soluble salt is there, then by dissolving them in mustard oil will distort the results. Extraneous variable. Don't boil this, for example, don't give it heat, put in pressure, etc. So control the extraneous variable. So the same condition should be there in experimental model and control model. Only in that way we have learned to control the variable. Then after that, experimentation. What is experiment? What is practical? What is activity? Experiment means I am given the situations. Let us find what happens. For example, in determining the strength of a solution, for example, more salt with some other solution. I am given the strength of solution of that solution, but in turn I have to deduce the strength of more salt. So I am experimenting this because I don't have the results with me. What's practical? When I know the things in advance, I'm just going to verify this. For example, to prove that resistance is directly proportional to the length of the conductor, or to prove that resistance is inversely proportional to the area of the conductor. Now in this, I have the things in my hand already. I have to just verify this, prove this. This is practical. What are activities? Activities means sequential steps of doing the things in classroom. Small acts doing the things in a logical manner. Because directly jumping at experimentation or performing practicals is a difficult task. So let them, the students perform some activities since beginning, since their primary or upper primary early stages, to conduct activities in that class so that an interest is developed among them. For example, using litmus paper in classroom, blue and red, and using different solvents, showing their effects on those litmus paper, how does the color change, can be conducted a beautiful activity in classrooms, so that students also realize that science is beyond laboratories also. If I have to confirm something, I need not to go laboratory every time. Nature is available with me as a laboratory. My classroom is available to me as a laboratory, so I can do the activities. So friends, what do you conclude now? What is science? Science is a content plus process. What is content? That is a body of information, knowledge collected through experiments and observation that comprises certain facts, concepts, principles, laws, theories, etc. Science as a process means the ways or the means to arrive at those conclusions. The dual nature of science is it's a process as well as product. Unfortunately, we emphasize upon product aspects, not at all on process approach. The different processes involved in the science must be taught to the students. The basic equation for equipping them with process approach is let them feel some problem, be sensitized towards some problem, formulate some hypothesis, do some experiment, and then deduce the results so that they can realize that science is for them and they are for sciences. Thank you.